Hi folks, this is Advanced Math, chapter on vectors, number 12, homework quiz F, recap. If you haven't taken the quiz yet and you're not sure what's going on, this might be worth looking at. If you have taken the quiz and you want to take another shot at it, this might be a good place to go for a quick review of your understanding. So, chapter or section F deals with vector equations for straight lines and the corresponding parametric equations for straight lines in 2 and 3 dimensions. So here we have what really is a three-dimensional situation, but we're describing it in 2 dimensions. A bird flies in a straight line with a constant velocity represented by the vector v with components 1 and 5, and is at the point 3, 6 when t, which stands for time, equals 0. Write equations for this motion in vector and parametric form. So the pattern for writing an equation in vector form for a straight line is pretty cut and dried. You start with the vector representation of an unknown point, x comma y. An unknown vector, basically, x comma y. It's similar to having just an ordinary equation where you start with x equals or y equals. But here we're just encompassing both x and y at the same time, packaging them together as a pair and calling that a vector variable. So the vector variable xy equals, and now we're going to have a constant vector that's sort of analogous to the slope in a linear equation. And in our case, the slope of a linear equation is the rate of change of y with respect to x. The slope in this equation really is the rate of change of position vector with respect to time. So that's what the velocity is. It's the rate of change of a position vector with respect to time. It's telling you how much the x-coordinate changes and how much the y-coordinate changes for each second or unit change in time. So we've got that vector right here. Let's plop it in. And we want to take that slope and multiply it by our independent variable, which in this kind of situation is just the time variable. So what this is saying so far is that for every unit of time that goes by, typically seconds, we're going to take another 1 comma 5 and add it to our position. So if this were 10, t equals 10, we'd have 10 comma 50 would be our xy position. Now you also need to take into account that possibly this bird was not at the position 0, 0 when time was 0. Because right now what I have here says that when time is 0, x comma y will be equal to 0, because 0 times 1 comma 5 is 0, 0. Well, we actually said that the bird was at 3, 6 when time was equal to 0. So when t equals 0 and what we have so far, this whole term goes away. So if we add to this the position as a vector when time was equal to 0, we have a complete vector equation describing motion in a straight line. So when time is equal to 0, this term goes away and the xy position is just 3, 6. As time goes by, tick, 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 we have an additional 1 comma 5 added to this for every second that goes by. And so this causes our change in position. Every second that goes by, our x-coordinate changes by 1 and the y-coordinate changes by 5. That's all. Okay, so that's the vector equation. The next part of this question says, what's the parametric form? So for parametric form, I want to point out that this vector equation is really broken up into x's and y's. I'm going to color code those with green and red. And the t, the time variable, is neither of those. But to write the parametric equations, I want to use the x components of this separately to write an equation, and then the y components of this separately to write an equation. So I'll start with my green pen, and I'll pull out the green parts and also include the t and write a single equation. So we have x equals 1 times t plus 3. And then for the y, we'll do this in a red pen. Y equals 5t plus 6. And, well, that's all there is. So again, this is the vector form. It's a single equation where the constants and the variables are mostly vectors. They have an x and y component. We're using it to describe motion of a point with respect to time, and so we do have a scalar time independent variable showing up here. When we break it into separate x and y equations, we're really saying the same thing. We just have a way of calculating x as a function of time, and we have a way of calculating y as a function of time. And that's what the vector equation was saying too. We have a way of calculating x and y as a function of time using these two constant vectors. So these are both expressions of the exact same thing. Now this form is particularly handy if you want to convert this to a Cartesian form, y in terms of x, and get rid of t altogether. But aside from that, they're basically equivalent. All right, that's the whole chapter.